Let us go ahead and get started. Welcome, congratulations, you did it, we're here. This is our final demo day. Kind of a bittersweet moment. That offer still stands. If we want to keep things going into the summer, just let me know. I'll show up next Tuesday, or this Thursday, next Tuesday. I have no problems with that. Otherwise, this is maybe the last I see some of you, so I'll try not to cry, but I make no promises. We know the routine by now, just to confirm, and maybe it's very obvious to everyone with regards to our time scales here, and then what you are responsible for taking care of individually. Definitely pay attention during the presentation. So you have this Qualtrics survey to have open, and just pop it open as you're doing it. Don't overthink it, but try to provide some nice feedback. So on the first slide, there should be net IDs for everyone in the class, and as well as for Jeremy here. And then as you select yours, you're going to have some version of everyone's rubric available. It should be the most up-to-date version. I just kind of screen capture that and put that here. You have little sliders here. I tried to include the right scale for those, but in theory, we could mess up and give 75 for something that's out of 37.5. Do your best, look at the final number, make sure it kind of makes sense. I think as important as that is provide some feedback. If you just want to say, great job, team, that's also fine. You don't have to write paragraphs. You're not getting evaluated on that. I will be kind of averaging all the numeric scores and collecting the feedback and providing those to the individual teams. Reasonably anonymous way, but there's only so many of us in class, and you can probably sort of figure out who is whom. So provide a reasonably fair job with that. It all gets kind of averaged out. If there's some weird outliers, if somebody put in a 0 or something, I'll look into that and remove those. And that'll be 50% of the score you receive for this. Jeremy and I will also be going through and looking at the rubrics and evaluating afterwards, and that'll be the other 50%. And you'll get the entirety of that score probably by the end of this week, and no later than that. We have until next week. I have here listed as 20 minutes for the presentation. I think we just have enough time here today, so take the time you need, walk through those aspects of your project, show off what your hardware is capable of doing. We'll talk about the bugs that you've had. We should have more than enough time for both Q&A and that peer assessment, and then go through your own rubric as a team and do your own personal self-assessment. Here's how we think we did. You don't have to be too easy on yourself. You don't have to be too harsh on yourself, just how you think you did for your own rubric there. As you fill out the survey and you get to the point where you are part of group 1, for example, just hit skip past it. You don't have to fill out your own team's survey for yourself. So as group 1 goes here, as Andrew, Gotham, or Maisie get to this page on the Qualtrics survey, just next and skip out of that. Or if you want to, if you're worried, you can write, this is my team, but you don't have to do anything. Just kind of skip past that, go to the next one, and then I'll be able to kind of remove those scores, and it'll be your peers' average and not your own self-assessment as part of that average. Otherwise, any questions before we get started? Because we're gonna get going here. All right. Without further ado, we will start with group number 1. Come on up. Try to speak to the microphone so we can capture your thoughts. Close the windows so you're not distracted by the external world. Of course, that's completely unnecessary. That's true. All right. Please, when you feel ready. Please feel free to go ahead and get started.
All right. Well, I'm Andrew. I worked on the texture driver and hardware. I worked on power and square root in hardware, and then debugging and some shader programs.
I worked on the divider and created test applications for the divider. I worked on an application for some lighting and helped out Maisie with some bump mapping. Also, my computer just didn't work, so.
I did quite a few applications for testing and some for shaders.
So big picture wise, one of the biggest things we want to do is finish up most of our tech debt. So that was the TLAS. We had some, division for perspective. And then the texture mapping. And we didn't do the Z buffer precision, so that weird thing with the end of the cube where it kind of offsets incorrectly, because it's just not worth the time and effort, and we had a lot more important things that we had to get done. We also got Phong light, or we wanted to get Phong lighting working in the GL application, and then also have it working with the hardware. And then we also wanted to get some normal bump mapping on a GL application and on the hardware. So that requires both the lighting to be working and texture mapping, as well as just some additional changes as well. And then yeah, the bare minimum was for us to have more stuff than MP4 essentially. So
Yeah, so I'll cover a lot of the hardware changes. These pictures are just, I guess, one of my first attempts at getting a texture and then one of the last attempts. But basically the hardware additions we have are these extra instructions, so the divider, square root, and power. We added some perspective states to the vertex shader, I guess also the fragment shader, and then texture fetching, and some extra fixes
What,
like
what do you think is happening in that upper right corner? 'Cause it kind of looks sort of checkerboard, but it's not the right amount of checkerboard, and it's all weird colors.
Yeah, so I think what was happening for a while is I was using signed calculations as part of my memory address calculation. So if you go past like 0.5 in the texture coordinates, it would offset negative from the base address, and that was just kind of garbage memory. So that's what was happening, I think, then. It was really weird for a while. I wish I got a picture of it, because I had like a quarter of the texture would load, and then the other 3/4 would just be like garbage information, because that's when it gets over 0.5 in both dimensions. But this is kind of a improved state machine for just our shader core. I kind of omitted some of the extra stuff that we know about. So we added like a couple extra stages for the actual instructions. So for the divider in the square root, we use like existing IPs that could do division, square root. And then we just have one hardware component for that we loop through with a counter. And the same for power is just a series of multiplies basically. And then, so we added the perspective whenever it gets a done instruction. It kind of just grabs whatever the output vertex is going to be and does some division also with a counter using the same divider. And then I have a additional counter to do it on other attributes besides just a position. So we have a control register that can set like if you also want to do perspective division for like attribute 1, 2, and 3. But I think that one might still have some problems that we'll see in some of the demos later. I don't know if all the texture coordinates are being properly adjusted by that.
So some driver changes. We had made some driver changes to the textures, which I think Andrew will talk about a little bit more later. And then for the shaders, I think Brandon's insight about modifying the uniform base address so that it doesn't overwrite the shader's base address came in really clutch. So yeah, and then we also wrote a new uniform for our lighting, the 3F, which wasn't all too complicated. And then you can see like we have for the Lua script many more instructions that we've added, like normalize, length, reflect, square root, fmax, so on. And we also had to revise the dot product one as well because it didn't work all too well. And now we are Lua experts. At least Andrew's a Lua expert now.
And Lua's kind of fun, isn't it? It's not bad, right?
It's okay. It was, I don't know. I'm kind of mad because I mistyped like the names of a bunch of variables, and it was hard to see when there was an error in the Lua script because it would just get like hidden and all that. So that kind of messed us up.
But we added
For
we added a debug feature, right?
I did, yeah. So sometimes it would say like there is a null character instead of whatever expected for like a register number basically. So I added like a print statement for all the like avenge, Swizzle, avenge, whatever, where it actually creates the binary. And so I just had like a Boolean to print out which instruction it was actually trying to create the bytes for. So that kind of helped to figure out like where the problem was coming from if we had errors compiling a shader. Yeah, so our texture driver, I have some like code snippets here, but we don't have to go into detail on everything. I basically created a couple like structures to do the bookkeeping in the driver. So that's what you see on the left. I have a structure for the texture itself that has like a size, a pointer to the data, and then the base address. I have a structure for like a texture unit because I don't know, to kind of act as a virtual texture unit since we only really have one in the hardware. And that just lets you bind, I guess, different samplers in different units so you can switch back and forth. And then just like a main texture state control structure, I kind of based a good deal of the driver code off of what's happening in like the shaders.c and .h. So that control structure has like arrays of all the units and texture structures and stuff like that. And then the actual functions we implemented are the GL gen textures, GL active texture, bind texture, text image 2D, and that's pretty much it. So then when we actually write a texture to the vertex shader, it gets copied to an extra memory space we allocated, and then the registers we write are just a base address, width, and height for the texture. And then kind of later on, I realized that it wouldn't be very suitable for having multiple textures at the same time, since there's only one base address for one texture. So I don't know, kind of after the fact, I was thinking about it, and probably what I would do is allocate a portion of that memory to be like base addresses of textures. So you could fetch the base address of the texture you want first, and then kind of get that width and height offset, or some kind of way to get that information from memory itself.
Or just maybe it's just 3 registers, or just a few collections of 3 registers might be another way.
Yeah, so that's how the texture driver works.
So we had a lot of test applications, around, I think, 18.
Yeah.
And we had like, 3 or 4 for each texture, lighting, and bump mapping, and then of course, like trying to combine them all. But bump mapping is both texture and lighting, of course. We have like videos and images in the later slides.
Yeah, so some of the challenges we ran into. Personally, I had a lot of trouble with variable typing just because I was not thinking that hard when I made them. So like when I did the width and the height originally in the driver for textures, I used like a UN8, which limited the size to 255 per texture. So whenever you went above that, it would write 0 as the width and height to the vertex shader, and I would just get black on the screen. And at the same time, I was having the issue with the like signed calculation of the address. So when my texture was below 256 for its width and height, I would get like a quarter of it working. And then when I got higher than that, it would all just be black. So for a long time, I really thought the problem was not copying over the data correctly from the driver until I looked again and saw that it was doing the signed math. And then I mentioned in the Lua script, I just like forgot to define a variable one time, and I don't know how it was very strange. It got our stuff in like an infinite loop on accident, but.
For the divider, we had an issue. Well, so the divider was technically working for the longest time, but we still weren't able to get an output. We were just like so confused what was happening. And then I think Joel took a look at our Joe took a look at our divider, and he saw, hey, this thing doesn't like use fractional. It uses like the remainder for when customizing the IP.
Joe Cankle.
Yeah,
Joe Cankle.
Well, I noticed that like the bits outputting from the divider were not what I was expecting. Like the fixed point part was kind of flipped or something. Like the fractional part was weird, and I was really trying to figure out how the precision works for like fixed point division and stuff like that. And then I asked him for some help.
Yeah, and that was just annoying, but we got it fixed, and that made everything else a little bit nicer and easier. And then lighting, we spent a lot of time yesterday just debugging, finding like small errors here and there within our driver code. And yeah, and just the fragment shaders and everything else as well. Yeah, debugging the shader was really tough, and I think the debug function that Andrew made for the Lua script helped a lot, and then just, I guess, understanding more and more, like, all the output that you get when you're running the shader helped us.
Yeah,
Um,
I found it particularly challenging trying to debug different shaders because it's kind of a black box when you send it to the Vertex shader IP. You can only really see like what goes in and what comes out.
right.
So
Yeah, and then everything in general was just, it was a fun time.
It seems like every team has a slightly different flow for how to deal with IP cores and Bravado. Just seeing the individual teams' comments. Maybe there isn't one right way to do it, or maybe we're all doing it slightly wrong. So,
yeah, the
you said
way
how to add an IP to an IP. It seems like every team had a different approach for how to make sure things were synchronized and not crashing.
yeah, well, the way we did the square root was kind of hacky because I added like a block diagram where it converts to floating point and then uses like the floating point square root IP and then converts back to fixed point. So it's really slow. I think it would have been better to do like a hardware approximation, but I kind of didn't want to spend a ton of time working on that, so I skipped it a bit.
So here are a bunch of demos. So we got the Jones cube working.
There's a higher quality picture of a Jones cube later on.
Later on, yeah. So the top one is orthogonal, and the bottom one was perspective. So just to test out if
I think you
orthogonal.
got them switched.
Oh, really? Is the top one?
Yeah.
Okay. Oh, my bad. Okay. Yep. And then yeah, and then this is like what we faced most of the time with the hardware lighting. Just that image over there. Because was it the specular or was that the diffuse? That
So
was...
that was just diffuse, I believe
Okay.
we were testing. So
Yeah.
you'll see there's kind of like a very distinct crossing between where it's orange and black. And so that was a problem where we were doing an unsigned comparison in the Fmax operation, which is something, I don't know. I kind of thought it was such a simple instruction, I didn't like ever really test it because I assumed it was working.
And then we
There wasn't much reason to test it either until this point.
Yeah, so that was fun.
I don't like the Jones cube. You can't tell.
yeah, we have better ones.
Yeah,
Oh,
I did
okay, that'd
another
be
one
fun.
this morning.
And someone has to leave that on the monitors. I don't think they'll touch the monitors over the summer.
Okay, I can boot it up on all of them, all the SGPs. This was my division test program.
He got jump scared. It was funny.
I did. I got jump scared by my own program.
This was just to test out division, yeah.
You can get the click. This was, yeah, so this is a little bit better Jones cube. I didn't have a ton of time to get the sizing right to be on his face this morning, but we could line it up better. And we got a Jeremy cube
That's
also.
great.
Yeah, so I think,
It's like his essence is trapped between that cube.
yeah, so I think for the perspective, you can see like the diagonal. Maybe it's hard to tell in here, but there's still kind of, it's a little bit weird to the center.
Yeah.
So I'm not, like Jeremy's face is a little bit distorted. Sorry about that. But I think it's pretty close. So I don't know if the perspective's quite working perfectly for other attributes, but it seems like it's working pretty well for the position at least.
Well, and did you, James, I forget who it was, but put a depth, so just providing more fractional bits for the depth information. Did you input that?
We didn't do the depth fix. So
I would be curious, like, because that turned out to just sort of work via a very small viewport change.
Oh.
That might be worth a quick try as well. See, with only that change in place, you can kind of fix some overlapping triangles as the viewport.
yeah.
Oh, this was the
Maybe
awesome
something
part.
else.
So this is when we got like bump mapping working, and
I
we
don't know which one is which. So.
yeah, and so they're all the same actually.
Oh.
I think some were cooler than others. So I'm just gonna show this one because this one was really awesome. This was our OpenGL application because unfortunately we weren't able to run it on hardware. Run it
Yeah.
again.
What do you think is preventing you from getting to work? So this is both texturing and bump mapping, or is it just bump mapping?
It's both.
Well,
Yeah. So you would have to have two texture units. I
Yeah,
guess.
so that's one thing holding us back from using this application. I think we didn't get to do like a test of just having bump mapping with like a solid color.
Right.
I think we could do one, we just didn't have the time to do the shaders and change the application to work that way.
Seems like it should, I mean, just bump mapping with just static lighting.
Yeah,
like a blue
pretty
cube
much.
or something could work, right? I mean, it's just a different shader, so. could
Yeah,
work for you.
so I kinda still wanna test that afterward, but we don't have a demo or anything of that.
No. Well, I guess we can show that as well, but that's just.
It was cool going inside the cube.
Nope. Go to the next page. Thank you. And yeah, go ahead. Okay, yeah. So this was our Fong lighting demo. So you can see like we have the specular lighting, I guess over here, the spec, and then the diffuse and the ambient lighting. So all components of the Fong lighting. So that ended up working well on the software and hardware side.
It's like slushy. Not very nice looking.
Yeah, I know. I don't know why he picked this color for
Yeah, I
the
don't know.
cube. It's like brown and
I-
orange.
I could change it.
It's a plush cube.
So, yeah, and then the hardware is on the right side.
Yep, the hardware.
So it worked.
Looks awesome. I don't know, looks like you would hope, right? For the most
Yeah.
part. And you chose an integer shininess coefficient, I guess, for that.
Yes, our power only works for positive integers
Yeah, but.
and 0.
I mean, it's hard to justify, 2.5 versus 2 or 3 anyway,
Yeah,
so getting
yeah.
it over integers, I think is just fine. How slow is it? How long did it take to get that image up?
Probably took, for this, 20 seconds.
Yeah, 20 to 30
I don't know.
for sure.
So we couldn't like move around like we could with the OpenGL application. It just took too long, but
So this is our grading. So for tech debt, we got a lot done. There's things that are still working 100%, but we also, I think, did more than what was needed to make sure our MP was running perfectly fine.
yeah.
Lighting calculations, we were able to do, the Fong lighting, which you saw in the demo, and we also had it on the application. OpenGL integration, I wasn't 100% sure what it meant by exemplary in this case, because it seemed really broad. So I think just because of all the debugging and everything, we gave ourselves extra points for that.
It's just uniforms, I guess, right?
Yeah.
So you did add some driver support to uniforms.
Yeah.
So that's pretty easy.
Yep. And then for bump mapping, we took off a little bit of points because we didn't fully integrate it because we still didn't get to test if it worked on hardware, or we did test if it worked on hardware. And there's still a little bit more changes that needed to be done, but we had it working on software. So
I'm pretty confident it could work, but we just haven't tried it, so.
right. And then regarding the test application, we did get a normal bump mapping with light OpenGL applications. So yeah, and I think we were like probably at 100 to 125 points. Yes, beginning of yesterday,
Yeah.
and we just
I was
grinded.
I was very proud of the work we got done
Yeah.
on the past day or two.
Yeah.
Any questions for group one as you're looking through the?
Yes.
Do you guys remember for the lighting, did you guys do like a point light or a directional light?
I think just a point light.
Okay, because it looked like there was like some type of like attenuation of like the distance of the light based off like the
Yeah.
the image you guys had.
I don't know, they worked on most of the lighting shader stuff, so I don't know what exactly you did.
Yeah, I think so. Yeah, because like when I moved the position of at least the spec. Yeah.
It looks like a point light to me.
Yeah.
Yeah, I'm sure it's probably.
Point
I
light,
would
yeah.
guess. I doubt we did a directional light.
Yeah, I don't think so.
Gotcha. You still need time to fill out your responses and make sure your numbers look good. Take a minute here. Otherwise, group 2 is ready to go. Please, come on up.
Someone this table is all.
We don't have time this morning.
This table is all up here.
No, you were late.
No, I got now.
Nope, you were 4 minutes late.
Actually, no, long time.
Like, I at least said I was gonna be late.
Oh, we're done.
So I think people have submitted their stuff, in Qualtrics, looks like it. So group 2, if you're ready to go, and you're prepared, and you know who's going to speak, and who's going to talk, please feel free to get started.
Okay, I guess I'm starting. Do you want us to go over our rules for this, or do you just want us to go over goals? Because we didn't do a slide for rules.
Present.
Okay. Okay. So our goals for this project were to just kind of clean up the previous MPs, because we got a lot of them working, at least up until like MP4, but there were a few bugs that we wanted to fix. We wanted to be able to do textures on our shapes instead of just colors like we've seen all semester. So instead of that gradient color on the circles, now add a texture. And we wanted to do that in multiple different shapes. Yeah, kind of. Ended up with a circle, chestodon, triangle, it's fine. And then being able to have hardware and software kind of look similar. There's, I think, a few fragments still, but for the most part, they look almost identical.
So,
Let's start with hardware.
So yeah, for how we fix some of the bugs from the previous MPs, they're going to be the landing, and then that's the test application just goes through a bunch of different landing modes with various alphas, colors, all that stuff. And you know, this one's fast, but ours is a lot slow. So
for software, for our OpenGL program, we modified a circle to have a texture image placed on it. There's some wrap option that you could loop through. And then for the driver, we added texture functionalities, and it support multiple texture units in the software side of things, but we only have one texture unit register, kind of like group 1, and so you want to start?
yeah, so the big issue I have with Vivado, just getting IP to actually update. So we make a change in the texture mapping unit, then we like synthesize everything, but it wouldn't update. And that was just really annoying because I would like update the debug register and that would update, but not the actual texture mapping file that I had. So that took a while to figure out, and then
And that's uncommon to me, I guess, right? So your texture mapping hardware was just some VHDL source within that same shader core.phd. And the register, I guess, is maybe defined in a top level component. So one of those updated, but not in the lower level file.
I found that
That's rough.
at some point it made a copy of the file I updated. So it's using that copy instead of the one I was updating. There's annoying because I would synthesize it in the IP itself, and that worked fine. Then it's like you go to the synthesize one to a project, and that's when it would fail.
I mean, sometimes, so you can only do so much with those like register groups. Sometimes I'll intentionally, add a syntax error into the file, right? And at least it should fail. And if synthesis is working, something is clearly wrong with what file it's doing.
Then we had an Opera 1 issue, so with the texture mapping, the clamp to edge, it would clamp a previous loaded textural and use that instead of on texture because it would go past on textual's image because again Opera 1. So.
Oh, and then for our driver code, it was really similar to the vertex buffer because I was looking at the driver and I saw bind buffer and I just decided why not reuse it for bind texture. And a lot of the code there does the same. The only difference is similar to the vertex buffer. When you call bind buffer, you could set the data, but you don't burst over the data to the GPU until it is specified in vertex attribute pointer, that function call. And it's similar here. GL text image 2D specify the data argument. Bind texture does not have any data argument to send data, but in OpenGL, you can just call active and bind texture, and it would just know where that pixel data is located.
And it's not clear, we talked about that briefly in class when we were talking about these functions. You would know them, but it's not clear when data should get copied over proof.
Yeah.
Spec doesn't say, here's when data actually gets, copied to device side. And I had mentioned in class, there's not too much harm in copying data over early. For the vertex data, we did need to know which attribute it was in terms of where to place it. But for the texture data, you just have this block of texture memory. Whenever you know what those bytes should be, no harm in just copying them over right there.
And then, so you could see the struct for the texture there. It's really similar to the vertex buffer. Here's more of the driver code. Bind texture, and then GL text image 2D, you can see over there, we're just bursting the data over to the GPU. And then text parameter FV, this for the border color for the texture, is also the same for the wrapping mode. It's just how we're writing the data over is different for the wrapping mode. But
for things like wrapping mode, is that just via, I can't see this and that's okay, but is that just via registers you have and the shader component itself, or you just, when you do the texture fetch, it determines what do I do if I'm outside?
And then I think the bit position is like the upper half is X, the lower half is Y, and then you just send the whatever mode the code for it is. Yeah.
So some fun OpenGL challenges.
So actually, let me go back, Shai, you can maybe show up 2 slides back. You say for challenges, would you describe those pictures on the upper, is that a challenge, or is that a successful result? It doesn't look quite right to me. I mean, it's like close, obviously, you've done really well, you have textures, but it doesn't, I wouldn't call that correct.
Yeah. That was the getting the color order right, and then it's also the images kind of like stretched beyond how it's supposed to, and that was just the GLSO issues. So.
We have multiple issues.
Okay, so that was a bug that has since been resolved. I can hardly see the colors, so I can't tell like how off the colors might be. That's just a me issue, but the stretching won't cause that kind of
I was
stretching.
gonna say the one on the left is the OpenGL, which is supposed to be like a blue, pink, or maroon.
Oh, 'cause I'm seeing kind of like cardinal and gold colors. So
Yeah,
it's
and so then on the
intentional.
other one, it's like a green and like a maroon, so bits were off.
And I think for that one, we just swap our blue and green channel on the.
Yeah, I see more like a stretch, so it's like we have
Yeah.
the rectangle.
And I think at one point our alpha got switched in our color order too. So
But those could be colors, is what you're saying. Okay, so when I'm seeing like a stretched bar, is that actually a checkerboard with just some wrong colors for some elements of the checkerboard?
No, that is actual like stretching. I think it was just I forget what this exact issue was to solve this, but I think it was there was newer script that will compound this for the channel, and it'll be kind of different than what our hardware was doing. So I don't remember exactly what this was, but it is fixed now.
So by the way, it's fixed. Let's go to the OpenGL. It's just OpenGL challenges. So we started out with our original test program, the whole circles, and this one was fixed so that we could actually see what's happening and try to put a texture on top of it. So those were supposed to be, so that circle and that triangle are supposed to be the same textures, but for some reason on the circle it would turn it, and we think that was how the circle was being drawn. That's since been resolved for like the puppy image that we have later on. But that was our first attempt to get textures working. So we could get something. Some we just wanted to make sure everything was working. Some we did the checkerboard triangles, make sure that was working. And then Joel was insistent on a beagle puppy. So we have a beagle puppy everywhere.
So did you just set, when you talk about circles and textures, so the texture itself is a rectangle,
Yep.
did you just set U and V to be equal to X and Y of the coordinate? Is that how you did the
I
texture
believe so, yeah.
coordinate mapping?
Yeah. And then, yeah, one of the
It'd be nice to
challenges.
see, because if you do that, where X and Y, well, you set U and V to be X and Y at application time, then you have a puppy flying through the screen, it would look pretty cool, I don't know, I don't know if you get the slow puppy.
There's a cone though. I think
Yeah.
the cone looks really cool.
I didn't like it. Anyway, so the one at the top was we forgot to update the attributes again to a 4 instead of a 3. That has since been fixed. And then Longwoods insisted on having random locations like we had originally. And so occasionally when you did the random locations, it would stretch the circle out to make it look like a cone. And then you would have those last 2 images. That no longer is in the application. Yeah, but it would stretch
This
it
isn't
and look
anyone's Beagle puppy, this is just a random stock image of a puppy?
Yep.
I'm sure it wasn't.
Well, yeah.
Yeah.
So, yeah, here's our demo. You can see it looping through all the wrapping mode. I don't know what's the order wrapping mode's in.
That's sped up, I assume.
Yeah. It's nowhere near that fast.
How come it's like stretch or lengthen this,
Which one?
the one in the middle?
That's the spherical open
Oh, was it the spherical one?
Yeah.
So that might have been the randomness that was being done. So if you got it just right and it was still in the center, it would kind of stretch it and look stretched, almost like it was adding us perspective. The ones around it are all just
Is that a
static.
circle or a sphere?
Yeah, is it on?
It's supposed to be a circle, but when you did the random locations for the circles, it would do it to a radius of about like 500, and so it would kind of stretch it from the center point, and that's why it looks slightly warped. But the ones around it are static placements, so that you could actually see the wrapping. That was more so you could see that during runtime you could kind of change the wrapping mode, so that you could have it be whichever one you wanted. And the colors change. If you run the application more than once, you get a different color for the watercolor. Is that right?
Oh, yes.
I can't remember the name of it. Next.
So, you want to go over for it? Who wants to go over for it?
Joel.
So, yeah, technical debt, we take it out and then you walk in, resolve issues with depth test, and I always have the bug, well, the texture doesn't like line up perfectly, so we have some lines going through the image, so whether that's taken out from the previous MPO, the texture mapping unit, it's still for debate, so. The texture mapping, we have the 4 wrapping modes, and so that's why it goes never past the 50. And it does like a flat image with a few minor issues.
And then we do support multiple texture in kind of in software side, but we would need basically a mux and some register on the hardware side to have more texture unit, more active texture unit to access at any given time. So we only gave ourselves a 50 on that OpenGL integration. And for demo program, I think we already went over that. A primitive, and we render it with a texture, and we cycle through the texture through the wrapping mode. Technically, there's 5 wrapping modes, but we only went to 4. There's one hidden right on the.
And that's all just kind of a big case statement or if statement within the shader itself. So if U and V is outside the range, do something. But I was thinking about that a little bit. So it's just outside the range 0 and 1, so you just kind of drop the integer component then. 'Cause I haven't implemented that myself. To do the actual wrapping, you go back to the picture in the previous slide where you have, I guess the upper left one's a good example, right? Where you have 4 puppies or whatnot in the picture, 5 in the picture. Would it also work if U and V was set to 100? Would it work for 100? It's just dropping the integer component for that kind of wrapping mode. Just thinking about that, what that would do for like the negative. But you have that version working too, so that's one where it's like flipped when it goes beyond. So you do 1 minus. I just wasn't sure how I would implement that. So if it's the wrap with flip mode in the lower left, you take like 1 minus the fractional component or something, that becomes your fractional component.
Just when you check the integer part of the fixed t, so if it's odd, you flip it. If it's even, you just look at the bottom.
Okay, so you have to determine whether it's working or
Yeah.
not. That would have been a nice, just one more demo to show would be like the 100 version, because then you can really see that it had that one working.
I think we can talk about
But even like the border and stretching and all that, it's, well, that's kind of cool, I feel like, you know, show that in theory it works, and in hardware, it's just, you know, as if everything is always a few bucks, and it shows that it actually works in practice here as well. It would have been nice to see some 3D, because it kind of had, it looks like, you could have convinced me that it was a 3D kind of shape there,
Yeah.
because there is what looks to be some depth and perspective. You're saying that's an artifact of how the circle and texture coordinates were generated. But that would just require getting depth, because they're almost independent of each other. Texture takes care of what the product should be. Depth determines which one you actually should have visible in the screen or not. Anyway, you can go back to your rubric. Any questions from the rest of the class?
What like file form or byte format did you store your textures like on the SGP?
Did we do JPEG?
On the,
Were they like fixed point values for the color?
no, it's just the 32-bit RGB
Okay.
value.
And then when you read it in with like text fetch, did you also convert it back to a fixed point there?
No, I just, well, let's see. Yes,
Okay.
so,
Because I remember I had to do that. It was weird.
I guess you could do it either way, right? You get to determine what your texture format is in memory. You do the conversion in the driver at that point to normalized values, and then texture fetch can be oblivious. Or if you're just reading byte values, then texture fetch needs, it's kind of a waste, right? Texture fetch needs to convert it to fixed point, and then render output converts it right back
Yeah.
to the other
I
side.
mean, that's how we did it in ours, and I thought it was weird.
I would probably done it in the driver, because that's what we're already doing in the driver for everything, right?
I didn't want to use up the extra memory space, I guess.
I guess we're okay, though. Oh, because you have to fetch that many more bytes, is
Yeah.
what you're saying, for the next fetch, yeah.
And then if you do 4 memory fetches, it's only 32-bit
Yeah,
wide
that,
data bus.
and it's just shifting, right? Is that what
Yeah, I did, well, because it's on 255, so I just shifted it to 256, and then if it was like supposed to be 1 instead of 1, I don't know, did you?
I didn't even do that, I just said, yeah, 255, 266, it's, you know,
It was
goes
real
down.
images, you probably wouldn't even notice. If it was a
Yeah.
black and white checkerboard, you would have seen that right away if you were off by 1, right? It would look all black if you didn't, the 255 cases. Other questions? Way to go, team. Alright, if you need a minute, take it, fill out your group 2's rubric. Otherwise, in group 3, you're really ready to go.
When's the last time?
All right, looks like people are done, so please feel free to get started.
Yep, so we did anti-aliasing and line rasterization. Our anti-aliasing was MSAA, probably.
Were there multiple samples?
There were multiple samples, and there was
Anti-aliased?
one fragment per pixel too, so.
So that's one thing.
Yep. Okay, so the way we did this is I modified the rasterizer. So instead of just taking one sample at the middle, I took 4 samples, and then I added up all the samples that like were true, and then I got the number of samples that were inside of the triangle. So most of them would be 4 samples. Some of them would be like 1 or 3 or 2 around the edges. And then the way we implemented this on the driver side is we just used the GL multi-sample enable. It was relatively straightforward. So-
You used the third attribute.
We did use the third attribute. That was, I didn't want to expand the bus because that would
That
take
goes
work.
somewhere.
It's gotta go
That other
somewhere.
information has to get passed
Yeah.
somewhere.
I just modified pass through. So here's some of the bugs we had. You can't really see all of them well, but okay. So the first one is so the top right there. One of my samples was always returning true because I just modified or coded something wrong. So you can see one of the triangles is always you get an extra triangle there that's a little washed out, and the next one, the bottom right, the edges are a little bit, you can't see it super well, but the colors around the edges are not quite right. That's because some values were overflowing or I wasn't doing the blending calculations quite correctly. And then another fun one, the bottom middle, was the way we were returning back to the rasterizer, whether or not a fragment was actually inside of the triangle, was if any one of the 4 samples was true or was inside, but that didn't include cases where the middle sample or the middle of the pixel was inside of the triangle. So there are some cases where the very first pixel wasn't inside of the triangle, so the rasterizer just stopped after that.
There's a lot of implementations of this that make some certain assumptions about everything being shifted by 0.5. That sounds like kind of what you did, or I'm not so sure, but where everything is not actually at integer values, and by making it 0.5, that lessens those.
Yeah, the way I fixed that is I just told the test to return true if the middle was inside of it, not just any of the 4 samples. So the results, it works. It's kind of hard to see from here, but the left triangle, it's a lot more smooth than the right triangle. And the bottom one, you can really see, you can almost see the different shades of the vertexes. It'll be a little bit more clear when we go to line rasterization, since you can really see the pixels. But
That frame buffer transmit thing didn't work anymore. I noticed everyone's still taking pictures. It should work.
the frame,
It
it didn't work for me. I don't know why. It just,
You have to have the application closed, I think.
that might be why.
Yeah, and then, because it's probably trying to do something with the driver at the same time. So
It's
I don't
other-
know.
yeah.
So you close the application, don't do anything else on the board, then you should be able to use that application.
Okay. I think you can make out the smoothness.
Alright, and for line rasterization, we basically did it exclusively in primitive assembly. We we used 2 triangles to make a line, which made it easier to implement the anti-aliasing, and also had the benefit of we could do everything in primitive assembly.
So who does the 2 triangles? I'm curious about that. Application code still just specifies 2 points for a line, 2
Yes,
vertices for a line.
yes.
And then primitive assembly turns
Yes,
it into?
it creates 2 new vertices, and the next slide shows how that works. But we didn't quite get the loop and strip working. I somewhat implemented it last night, but I had problems and wasn't able to test it. So it doesn't really count
And
for
the
anything.
line interesting.
Yeah.
I don't know, it's a
Yeah.
line, so add one more line.
But yeah, you can see this state machine here. It's basically just cut out everything that was not used for lines. You don't need to wait for V2. And I think there's 2 line calcs there. I think we only have 1, I'm pretty sure. But other than that, no, there is 2. You're right. I don't remember. Yeah, so you can see there's the 2 line points, and then we generate T1 and T2. It's basically we're estimating where to add on our offset based off what quadrant the points of the line are in. And basically, we want to create that shape, right? And
Go back to that.
Yeah.
This is obviously pretty critical. And my understanding, this is how modern hardware would do this, or something very close to this is how modern hardware would do it. Talk about the quadrant. So you wanted to determine whether it was a tall or like a wide line, basically.
right,
based on
because
how slow.
if it's like a vertical line, you need to add more width to it, right? In order to get wide enough fragments that it would actually draw something. But if you just did that, then if it was a horizontal line, you get nothing, basically, 0.
So you do it based on slope, right, not on quadrant?
Yeah, so I have gone through this part because we were getting some bugs before. So what happened is I would do division, but that's a lot of work and I didn't have a ton of time. So I didn't do division. But if we use the quadrant instead, we can get a line with in between like root 2 over 2 and 1, which looks like a line that are about the same size.
What's it called, quadrant?
So-
You mean normalized divide, I know what quadrants are in a Cartesian plane, but in terms of normalized device coordinates?
So if we have a line here, and then we have like our vector that we want to add to our line to get the width. If we have a line here, then we can add this vector, and then that will be a triangle that's like the right width. But we can't add that line here because we'll get like a 0 width line. So if we're in this quadrant, then we like rotate it.
What's quadrant to do with slope though? Could you just have, okay, continue, please. No,
It's because I didn't want to do division.
okay.
So I think we had it, so we have, if we're in the first or the third, then y equals like, then we subtract the y from the vector.
And that's what you have here on the slide, right? If in quadrant 1 or 3, then you subtract some width from the y dimension.
Yes. But if we're in quadrant 2 or 4, we add to the y dimension.
Is the vector always positive?
Yes.
Okay.
And then we just like, we'll get a line between width root 2 over 2 and 1.
Nice, and I don't know if you had time to create like a line paint kind of application, like the triangle paint one, to kind of see like, as you drag the line around, you know, how it gets rendered.
We did do that.
Yeah, we did.
You did, okay. That, you know, I have to look at it, reflect on it a bit more. I don't understand it, right? Because I don't see, quadrant is something in terms of positive or negative, I guess, but what if you have a vertical line in quadrant 1 versus quadrant 2? Why do you treat it, or a horizontal line in both quadrant 1 and quadrant 2?
I mean, I think if we had a vertical line, then we'd add that vector to it, and then we get that, and it'd be like here and here. So it would be width of root 2 over 2. And it'll be kind of like a parallelogram, but it looks fine. So, okay, so for the line issues, the top right, it was a very thick line, which was an issue kind of with what we had before, where we were not using the quadrant, so we had a line that was like here. Okay, so we drew this parallelogram, but it was just thick because we had a higher line thickness because our initial line was like this and that was parallel. So we changed the line slope and then we got a really thick line because of the estimations that we weren't doing before. And then also our raster still doesn't work 100%. It mostly works. Some of those lines, a lot of the lines look better than that.
Nancy fixed it a little bit.
The root value from before, when you calculate, is that just like a constant?
It's a constant that we assign in the driver,
Okay.
just so I could test it easier.
I mean, I wonder if you sometimes still have like area 0 triangles, and what your rasterizer does, you give it a area 0 triangle. I don't, the triangle setup will generate something for you, but what your iteration, it may just crash, it may just get stuck in the loop in the area 0. And that may be just a thought.
So you can really see the anti-aliasing here, I think. The left line, very choppy, right line, very smooth. And then we did modify TriPaint to work with lines. You can see sometimes the rasterizer dies, but looks like a line.
It looks like it works specifically what
It crosses the
Crosses that Y, that X.
That's probably why. Yeah.
It becomes a sliver and then, once it goes to
It's
that,
only
that
Well, I
top
can't tell what the mouse is doing at the same time, so that's the problem, right? So that's the hardware output, so.
Yeah.
Is it just, is it meant to be just a clock, or are you just dragging?
I'm just dragging it around. I just changed TriPaint to be.
That video may be more valuable with like the CPU version kind of side by side, you know, what the inputs are.
Yeah, the hard part, you can't really see the CPU. If you're that far away, you can't see the lines.
Oh, maybe there's some line thickness parameter. I don't know. Okay, so you can't even really see them so much
No.
on the CPU side.
I think, is that it? Oh, yeah, okay. Here's our self-assessment. We didn't have a ton of previous tech debt, but our RAS strategy still didn't work 100%. And yeah. GeoLines worked, in my opinion. And then MSAA worked. We interfaced it with OpenGL, and yeah. The drivers all worked. The drivers were very simple though, but yeah.
Yeah, I guess what all did you get at the driver?
not a lot.
We just, all we had, it was all like implemented for us, I think.
Just type information.
It's pretty
I guess.
just type
That's it.
information.
Maybe
Just
type
another
it.
value for a new type.
Yeah,
Visual lines, that's it.
and like graphics, and just the line width, which we did in graphics in it.
not with constant.
Yeah, which was just one.
We'll go group 3. Wow.
We can just start clapping at this point, right? Because like there isn't many other classes happening. Or
It was to save time, not to, it's not
Oh,
for that
We have
purpose.
plenty.
yeah, we got time.
I think we're good. Group number 4. Come on up.
I would just like to take a moment before we get started. Whatever professor or TA wrote these circles,
They're really nice. It looks like a three-dimensional shape almost, doesn't it? Like
they're wonderful.
Yeah.
They're great.
I've been described it like that as well.
That A circle is especially nice.
You lose like 2 marks. It's hard to see from where you're sitting, but it does it has a forehead up there. We're kind of
Yeah.
Easy, basically.
Is it distance and without my glasses?
Yeah, just take off your glasses and it looks perfect.
Well, if I think I'm like that.
Yeah,
Alright, team. Go ahead and get started, and this is it, right? I mean, so, no pressure. This is kind of the final memory the entire class will have of this course, based on the quality of your presentation. and depth.
Don't worry, the presentation is perfect.
Excellent. Please get started.
I'm gonna go first because I'm a narcissist. My name's Will. You should know that by now. I'd feel bad if you didn't know my name. I worked on lighting hardware instructions. I did the first attempt at the square root block, and Brandon fixed it. I did a whole bunch of Git reorganization because we've been working off the same branch that wasn't the main branch for the last 3 months or whatever. And then I did a bunch of testing for the instructions and stuff. Go ahead,
Okay.
friends.
I first did the W division when we started, and then I kind of transitioned over to fixing our def bugs that we saw during Cube Flyby, and then in the latter half, did mostly software work with like OpenGL and a lot of the shader stuff.
And then I did drivers and worked with the compiler. There were some changes we need to do in the Lua script. That was a lot of what I was doing. And then we did, Will and I did a lot of the lighting hardware instructions together. I fixed the square root module, and yeah.
Sweet. So our goals, we wanted to get Fong and Garrod, I feel like there should be a second R, but garage lighting, we got demos and we wanted to show all the steps in the lighting process, and then we needed to complete necessary hardware, like the square root division. We got another slide for it, min, max, that kind of stuff. Normalize. And then ultimately, the big one, the bottom there, is just trying to understand. I just want to know how it works. So here, we got our tech milestones. So, very important, we worked on depth testing, alpha blending. That's tech debt that we were catching up on. Cube flyby with perspective, more tech debt. And then finally, we can start working on Phong lighting, running a full blend Phong on the hardware is like the dream. What we actually need to get that lighting going, for hardware we need square root, F division, perspective division, and a minimum, what's that called? Operation added to instruction, added to the shader core. As for the driver, one element swizzle became a problem. We need min and max in the driver and length. And then we had to add a new uniform, the 3 float vector.
Same issue the other team, your team had as well, or which team was it? That you were 3F?
Yeah, it was that.
3F
That was-
versus 3F just means
Vector.
providing 3 scalars versus providing 1
Yeah.
vector. So,
That was a whole mess, was not realizing we didn't implement 3F, so we were passing in a 3-foot vector when it was
maybe
taking in
it's
a
just
4,
kind of confusing.
and then it just, all the rest of our uniforms were like offset by a float, so it was really weird.
Oh, I forgot I did this. Whoops. They're all offset now. But that's okay. That's supposed to be on top of max because we already have it. And then min, or I guess length, is that we're going to do it in the shader. And then I did my best. I blame James on that one. And then one element swizzle, it's kind of a non-issue because you can just work around it in your shader. Yeah. So, did I get everything on? Yeah, I did. So, square root. We found, well, we'll start at the very beginning. We went on Wikipedia and found the best way to compute square root in binary. And then I implemented that, and it worked great until I remembered that we had to do 16.16 numbers. So I made
Is
it.
it not the same?
No. I made an integer square root that worked great, but it doesn't work when you have to take in account your fractional part. So then we found a lovely Git repository from CH Mike, or whatever his name is, who has a bunch of C code for fixed 16.16 square root. And then while I was panicking on why it wasn't working, Brandon just like sat down and fixed it in like 4 seconds. I don't know.
Would you be willing to we have time. I don't expect you to be like an expert as to why everything works. Can you kind of walk us through a little bit about what you think is happening with CH Mike's code?
I can definitely try.
Okay.
As far as I understand it, you are making like an upper end guess here, like so this is just the biggest possible number you can get without worrying about signed, right?
That's like the largest unsized integer that could possibly be the result of a square root operation.
Correct. Yeah, you go as big as you can first, and slowly, as long as it's not, I don't know why, I guess this would be your bottom half. 4 here would mean, I don't know why it's 4.
Well, 40 is, we could
I used to
figure that out.
remember.
That's, if you think of that as like 6 zeros and then 40,
Mhm.
that's 2 to the negative 18, right? So maybe is that also possibly the smallest value that could possibly be the result of the square root? Because it's the same kind
Is
of
that just
thing, right?
like when we decide the break, when it's good enough?
Yeah, I guess that's the.
That
within
was,
within that amount of precision, maybe.
Yeah,
is what it
probably.
is, okay.
That,
when your change in the estimate doesn't, it's like that kind of thing.
Yeah,
right?
yeah.
It doesn't change by that much. You converge well enough. Okay.
so there were only a few differences between this and the integer square root, and that conditional, the b greater than 0x40, that was one of the changes. In the integer, it was greater than 0. So that might be part of it. It's for
Yeah.
the,
It ended up with wildly different answers,
Mhm.
so we just stopped touching it. Ultimately, from what I understand then, is once you sort of, as you're moving down, you then sort of guess at what the non-perfect amount is. Like if you're working on a perfect square, you'll just get the answer, but if it's a non-perfect square, you have to kind of guess and see if it's close enough. And then if it isn't, you increment your value out of the way. I don't know.
Perfect.
Yeah.
That's interesting. I mean, and I'm guessing, given that C code, the VHDL is pretty straightforward, right?
Yeah.
It's almost like a one-to-one mapping to the corresponding VHDL.
Yes. I wrote the first version of that middle block there, the VHDL, and then Brandon fixed it.
like I said, there wasn't a whole lot of difference between the integer and this floating point, so it was a pretty quick change.
Yeah. It's its own custom separate VHDL file, so we had to add it to the rest just as a component to the Vertex shader core. And
That was such a redo.
Vivado hates that. Well, for Brandon, it hates that. For me, it was fine. I just clicked it, I dragged it in as a source, and it just worked, which is great.
The issue becomes, and I wrestled with this as well when even like putting together class materials, you have to give it like relative path. So you have to maybe manually edit everything in relative path. So it'll work just fine for you, because it's using your like home directory or something as the path for it. You never have to go through and make everything relative path. But even then, sometimes it changes it back for whatever reason, depending on which editor you use, it changes what the path is. Interesting.
Yeah, and then I did a lazy little state diagram. It doesn't really mean anything because you can't see the math inside of it, but it basically just the 3 states that it has. Oh, Brandon, you had a brilliant idea to keep track of the done signals.
I did.
Yes, since this is a square root for just a single lane of our attribute or whatever, we have to run it 4 times at the same time. We just made a generate loop and have 4 of them sitting in each vertex core. And so they all have to do square root on their own, and it takes different amounts of time depending on what number you feed in. So he wrote a little catch that finds when all 4 are done, so we can move on to the next state in Vertex Shader. And I don't know if we took pictures of that code because it was...
It was just another process, but it was the sensitivity list was the done list, or the done signals for each of our 4 square root modules, and then a reset signal.
That's a little tricky though, right? Because the done only goes high for like a cycle in this individual
Yep,
component.
that's what the
So you're actually
process
inferring a
will do.
whole number of latches in that process, but it's probably okay because you want to kind of store that result.
Yes, division and power. So James did division first.
Yeah, I added the original divider IP to the project, and then we did the prospective division before the instruction division. So once they started getting work on the division instruction, a lot of the like structure was already there to kind of do it, because we did the W division basically just at the end of the fragment or end of the shader core. So as soon as the done signal is caught by the instruction memory, then it just does the W division if the W doesn't equal 1.
So it checks that.
Yeah, it'll check W, and then right before it leaves the shader core, it'll do the division, which was mainly just so we didn't have to add multiple division IPs to the project. If we were to do any type of like, I forgot what it was called, the stuff you do in between the shader and the perspective division. There's something called in the pipeline. What is,
Rasterizer?
Yeah, that stuff.
something. There's stuff there, but yeah. So
We talked about a decent amount of the class because it's not really clear to me how does this happen in practice. Because I can imagine this also be kind of a driver thing as well, where you have just a division instruction or a vectorized division instruction, and then you're shader compiler determines, and just generates the code to basically optionally do that perspective division after all your other user-specified code is provided. But either approach is good. You're recognizing, well, we only really need the divider at one time. Use it for both purposes.
Yep.
And then here's the stuff for power. I didn't work on power. Who worked on power?
I did.
Brandon worked on power.
So we were kind of running short on time when I was doing this, so I just did a couple of different states and did it one by one instead of doing it vectorized. But it's essentially just a bunch of loops doing multiply, so we only do integer power.
I guess if you have a square root module, then you can integer power and then round to the nearest power. Right? There's ways you could do it. I think for what we're using it for, integers is more than
These are our shaders that we use to test. The one on the left, your left, would be the FDiv. They're all really boring. It's literally just, divide the position, make it smaller. FPOW, similarly, that written right now, it just says the power of 1, but obviously as long as it's an integer, it does it.
power of 2.
We have
We have a photo. It does not stretch it. It looks kind of funny. And then, this is for length. So a square root test.
So that was just calculating length manually, doing square and then square rooting it. Or does it do square?
You
Yeah, it
provide the
does.
length as an input. F is the length, and then you calculate the square. Cool.
Ah, yes, the depth buffer precision bug. This was just really annoying, and this on top of like our depth buffer being broken. Our original flyby cube just looked like trash. It was not.
I don't think
did
it
not
was
look
just
good.
you. Didn't everyone's basically look like this, or did other teams not have yet?
This was after I fixed a lot of the depth buffer stuff, so the triangles are actually in place correctly, and this is just where it has the depth buffer precision issue. And that was after debugging it for how long. The fix is ultimately just converting the 16.16 Z value to a Q8.24 in the range of 0 to 1. And it was literally like those 2 lines and then a couple more lines on the driver, and it ended up not being too bad. And we have pictures later of the flyby looking pretty crispy.
Because all the comparators you do with render outputs still work. They don't really even care about the precision of the comparison. They're just checking which one's bigger than the other, right?
And it was basically whichever one was there first got priority. You can talk about the uniform and DMA.
I think I did the DMA. I can talk about it.
Yeah, go ahead.
So the second one there, we had challenges with the uniform memory locations because we had MVP transform for our vertex shader and we had lighting calculations in a fragment shader. And we found that the compiler was not changing the uniform base address for those 2 shaders, so they would end up overriding each other. So I just changed the Lua script so that the second shader's beginning of the uniforms will be changed to the space directly after the last uniform in the previous shader.
Because you have all that, all that information. You just have to tell it start here versus start.
Mm-hmm. And then
You can talk about the other one too.
so we also found that we were doing a lot of unsigned addition and multiplication in our hardware, so we had some issues with the dot product causing underflows. So we were getting, like on that cube there, the right yellow side should have been black, and it was yellow because it was underflowing. So we changed our addition to signed, and that fixed that.
How do you track that down? I mean, that seems very subtle.
It was. Yeah, I don't know. You caught it, right?
It was last night. I don't remember what I was
in
doing.
the zone.
We were both staring at the shader and we were like, it's happening at this line, the dot product line.
How could you even determine? So you had a good enough test infrastructure for your shader that you knew like, okay, the result is wrong?
Yeah, so we were able to change all the values of the different strengths of the lighting calculation. So we basically, in that picture, only had diffuse lighting. So we knew, okay, it's taking, the face is away from the light. That means the normal should be negative, or not the normal, the dot product result should be negative, but the negative is resulting in a maxed value. So we knew something was happening with like overflow or like clamping or something like that. And then Brandon just,
I think what I did
Spotted
was
it.
I just started looking through instructions and found Ad was doing unsigned edition and changed
Yeah.
it.
oh, and then one of our MP bugs that we fixed, previous MP bugs, was that we weren't DMA weighting in between clearing the depth buffer and color buffer. So our clearing the depth buffer would just basically overwrite clearing the color buffer.
Yeah,
You get like
it's the
garbage
same
values.
DMA engine, right? So I don't know
Yeah.
what happens if you give it a second request before it's done.
All the colors were messed up, like complete garbage values. It was a pretty wacky result. This was super interesting. In the bottom picture, I'll get to that. One of the things in the OpenGL code that we struggled with, or I struggled with, was the coordinate spaces. I was originally using the post perspective normals and positions for the lighting calculations, which is just like entirely wrong. I ended up just doing everything in the world space. I tried doing view space, and I don't think I quite got it. I think something wasn't in wasn't in view space. So when I was rotating the camera, the lighting was also rotating with me. Some like weird bugs with that. So I just ended up doing everything in world space.
So you don't do the perspective matrix. The way I see it done, you use the model view matrix for the normals, and then they get stretched so you have to renormalize the normals.
Yeah. I couldn't quite track down what was the issue with that specifically, but I ended up just passing in the model matrix and going from there. We ended up having a multiplication overflow during the when we were normalizing light direction, and Brandon kind of helped fix this. There's a garbage yellow line inside the wood texture that is basically when it overflows.
You can see it really clear on the dark face.
And that was fixed by clamping the multiplication on the high end of the multiplication instruction. And then we also had a lot of issues with OpenGL and SGP OpenGL differences. Like the swizzle operator was really annoying, and like doing multiplication with the vector first and then the matrix, like weird things like that were just like silently failing the shader. Like no, it wasn't crashing, it wasn't doing anything like that, but all our uniforms were basically blacked out, and our inputs were off, things like that. Just kind of abstract things that were kind of hard to understand.
Going back to that picture, those like curved bands on the surface.
Mm-hmm.
That has to do with the multiplication that we were doing was dealing with the X and Y, and I think Z as well. So it would be changing over the course of the fragments here, and so some areas wouldn't overflow, and some of them would. So that's why you got
There's
these
some
weird bands.
overflow, three-dimensional overflow,
Mhm.
anything like that.
Yeah, and the light's obviously in the bottom left, and it kind of like radiates out from there. It was pretty interesting, and that was a result of. I actually forgot.
When we were doing the multiplication, we stored it in a W fixed T, and then just
Oh yeah.
grab the middle for the fixed T. But
That's not correct.
yeah, so we had to add a state to check whether it was bigger than the maximum or not.
Okay. Now this is the stuff that we actually like is working. Obviously the depth tests and the alpha test were the two biggest MP bugs that we fixed from MP4 and 3. And then the pictures on the right and bottom right were more of kind of what was broken before with depth testing. The bottom right picture, we had some triangles poking out. Same with the bottom middle one. And then the top right one is obviously the precision issue.
That's awesome, right? So that looks about spot on, right? For what
Yeah. With the precision, since we're not doing any culling or like back face testing or anything. At very small triangles or small cubes, we'll have like pixels pop out just from the back face, but it looks really good when it's like a big cube on the monitor. Oh, this is the fun stuff for what I was doing with the OpenGL apps. These slides I'm just going through like each step. Ambient, super easy to calculate, it's just ambient strength and whatever color it is. So the left is the high strength and the right is the low strength. That's pretty self-explanatory. But we have diffused lighting, and this lighting application I made was kind of like one of our final applications. And that was where I could move our camera perspective kind of like flyby, and then I could also move this cube, the white cube, which is our light source in space. So this was a really cool application, kind of like fly this light around and kind of see how it interacts with the cube. And then we can also change the strengths of everything and the shininess and stuff like that. But this is our diffuse, pretty self-explanatory as well. So that was the whole big thing, was I was trying to have two different shaders with a light shader.
But we didn't test any of that.
But we can't have two shaders like loaded. I wasn't going to deal with all that. So it's the same shader, but I basically passed in a bloom float, which if the float is 1, then it just it just blows up the white cube. And this was purely mostly for testing reasons, just to see where the cube is.
Because that would otherwise require 2 shaders.
Right,
One
exactly.
for the light source shader, one for the.
And so we were able to just use the same vertices and translate them differently and just blow up the white cube color values. That was really cool. Because I wrote an entire application with multiple shaders and things, and I realized it didn't work.
I think if that were your project idea, we would be able to get that to work. That's just managing the resources and the driver, uniforms and the like.
And then swapping out
instruction
vertices.
pads,
Yeah.
it would be doable. That's
Yeah. And then, oh, this is cool. Yeah, so this is our blend specular shininess. And so you can see in our view direction, and I'll explain that later, the first vector that we define. This is a point light since, or not, excuse me. I'll get to that later, I was getting ahead of myself. But yeah, these are the different shininess. The one on the left is very high, and the one on the right is lower, and you can kind of see all the specular lighting kind of reflects off the cube and the viewer. And this is basically all of it in one, kind of showing what the application kind of does if I just automate the light, which is pretty neat. Oh, it was.
very nice.
I sat there and just staring at it for a long time. It was a lot of fun. And the result there is just the addition of all the different lighting calculations. This is to fill in the checkbox for having a demo that wasn't just a cube. So we loaded up FlexSeal into our old application, the one with the cube. Just basically replace the cube with seals. So I showed ambient, and this is diffused lighting. And then I'll show just specular in a second here. This is specular. And I'm going to mess with the different strengths of specular, so it's going to get really shiny in a second. I think now it's going to get shiny.
Steel seal.
No. Steel seal. There it is. Now it's super, super shiny. And it's kind of cool how it all reflects off the seal. And then here's everything kind of together. The ambient's a little bright, but yeah, it looks good. Pretty cool.
That looks incredible. But I'm guessing still our rasterizers are still not robust enough to handle it.
Absolutely not.
That's a shame. And that's how it was 2 last minutes. That's how I was suggesting for people. Something in between cube and 100,000, face seal would have been nice. But,
Yeah.
Oh yeah, here. So here's the demo for all of the little ugly shaders we wrote earlier, little joke shaders. So on the left, you got a lovely little pink triangle. It's technically blue on the top and red. It's the same as the other triangles. But we added a square root to the color, just to test square root. And then, oh, yeah, you were asking about FPOW to the squared triangle. I think that's also divided by 3 just to make it smaller, but instead of it being in the center now, all of the gets thrown into the corner. I believe that bottom corner, so the original locations were 0.9 for everything, like minus 0.9, positive 0.9, whatever, to get the 3. I had to change one corner to 0.8s instead, otherwise it just makes a line. Yeah. And then it doesn't want to rasterize, obviously.
One bug we did have that this application helped us find was we were doing unsigned multiplication in the POW as well. So our right side triangle, the one that's on the hardware, was flipped. Like one of the vertices was on the bottom when it should have been on the top. And that's because it was doing unsigned, so squaring a negative would still result in a negative then. So we just switched that to signed multiplication.
And I can tell if projector artifact or are you missing
That
a line
is
in the
a-
rasterizer here?
I'm not quite sure what's going on with that, but yeah, there
There's
is.
a rasterizer, small little traversal bug that will do.
Yeah, and then FDiv is just small. He's little. Yeah, it's pretty easy.
This is kind of self-explanatory, you don't have to watch the whole video, but it's just the perspective division and depth working very slow, obviously. Yeah, that's about it.
That's awesome.
Okay, so this is the cool, kind of showing the difference between a point light and a directional light and the code that's different. On the right side with the point light, you take into account the actual fragment position. And the bug I was talking about earlier where we were doing that post-perspective was we were just taking frag position, frag chord position from the shader instead of passing in the actual world coordinates. And so the point light, we kind of exaggerated it a lot, and this is only diffuse showing, so you can see how it kind of gradients when you use diffuse lighting.
So that world position had to be an extra attribute you had to pass on.
Yeah, that was an attribute that we made in the vertex shader and then passed it on. And then this is showing really awful pictures, but the difference between the different shading calculations per vertex and then also per fragment. So you can see like the triangle line that comes down as a result of the vertex for this triangle right here being black and the result for this vertex here being a little more orange. You get like a weird line where like that is much smoother. And
So the artifact I'm seeing is that just taking a picture of the screen.
Mhm.
Oh.
Yeah, that's yeah, my phone camera not being yeah. And then these are like each of the steps for each of them, kind of the same as the application, but yeah.
This time with hardware. Yeah, it's the exact same thing that James was showing, just with the hardware component now.
The previous two ones were on hardware.
Yeah, these ones are hardware, and these ones are hardware here. You can see diffuse and ambient, and then just the specular in the bottom, and then full on the top there. And we tried to move the light source around so that it would be a little bit visually interesting, but it didn't really end up doing anything.
It was also the cube moves in 3D space like one step at a time. So trying on the hardware trying to move the cube
You press L and then
was miserable.
it
What
ticks.
was the latency for you guys? So they had about 20 seconds for
If- If we ran full Phong lighting on the fragment shader, we would get a frame like every 7-8 seconds, 10 plus sometimes, depending
Yeah,
on, it all depends on the size of the cube.
The very first startup takes the longest, but each frame.
And SPF is pretty good.
It's not terrible. Once we put it in the fragment shader or in the vertex shader, it was like just a couple seconds, which wasn't too bad.
And here's our lovely diagram for all those inclined. As for our technical debt, we got a whole bunch of stuff done. Oh, I forgot I did those.
You
Yeah.
can just skim over it.
Yeah, technical debt, we did a whole bunch of stuff, but really the part that we're missing still is that some triangles will just sort of give up on depth and just appear because they want to. And then we have to wipe the board or like reprogram the board after running a program every single time. Otherwise, it keeps running what we put on it last time. I don't know. I think that's an instruction issue still that we just kind of gave up on before. And it's just slow. It's just slow.
How do you fix it slow? Let's say we have all of this. Actually, this is performance. How do you fix this? Because it's very slow. I understand.
At the very least, parallelize more of our instructions because we're doing a lot of sequential stuff.
If you had 128 of those tracking shaders,
Mm.
it might be okay. Each of them individually would be relatively slow.
I think implementation-wise, we kind of left parallelizing stuff on the back burner. Like just as, it was just very intuitive to just do everything sequentially and then we just kind of rolled with it.
And your team, or did anything run into any synthesis timing issues? It just all how it worked from that perspective? So that was always my concern. When you add some functionality that I know conceptually should work, but haven't actually implemented myself, you never know. Which extra little module is going to blow up everything? Didn't happen for your...
I think we consistently had like 30,000 negative slack or something,
That's
negative
pretty bad.
30,000.
So it was always failing.
It was always
But
failing,
it's
but
happy.
the program still
It
ran.
wouldn't crash the it wouldn't like crash and burn, which was nice, but it was, I'm sure one little thing would have blown it up eventually.
Yeah, we had the same thing, but I think if you look in like the timing report, it was all in like the setup
Trying to set up
phase.
still.
For like when it was resetting all the signals, like sending
Yeah.
reset signals, that's where the timing wasn't meeting. So I felt like that was.
I don't remember where ours was.
I never
really
looked at it.
I looked at it and I wrote it down somewhere, but it's long gone.
Well, those reports aren't always that useful because when it fails many ways in many different times. It'll give you which paths are the longest, but that doesn't actually mean that's necessarily the first problem there. So that's a whole separate kind of thing to learn as a design engineer for hardware. How do I go about fixing time distribution? So it's nice. You had them, they probably made your replacement route slower each time because when it fails, it keeps trying.
Yes, it does.
Until it can reach
The place
the
route
solution.
is very long.
Yeah, so that's frustrating, but the fact that it still works is nice. You shouldn't assume that when you go out into the workforce that it failed time to me, but hey, it seems like it
Hey,
works.
ship
It's
it.
very nice. But for now, it's not.
Yeah. Lighting calculations, I mean, we did all the hardware support from Max, Tot, Normalize. Specular, we needed POW and like square root as well, so we got that sorted out. And then sources, we got the directional point light and we showed the example of that.
OpenGL. I don't remember why we didn't do. Oh, we didn't do full points on OpenGL because still got those some weird buffer issues with consecutive programs, and that's probably a driver issue with the buffers. But we kind of just. Oh well.
How does it matter? That seems overly harsh on yourself, but it doesn't really matter at the end of the day.
And then James went absolutely crazy on the test programs, so he went bonkers. Did you put in the videos of the
Which one?
I think
the cool the cool gamer one?
Which
Oh, he put in like mouse.
Oh
Cam-
yeah, no, I ripped a camera class off of Learn OpenGL, and I modified it so we were able to like first person like zoom around the cube, which is super cool. But I didn't have a video of that.
Yeah, it was great. I have it on our drive.
And as we talked about, I think that's the way you have to do it. You have to have separate tests, shader tests in our case, for several games, for every little thing you want to add. Because otherwise you have this scene and it doesn't work, and you really have very little, way to investigate underneath.
We're trying to be super aware of like we couldn't have a super dynamic thing to test, otherwise it would look like really awful. We would just kind of have that static scene and we kind of manipulate it one step at a time, which kind of helped a lot. Like we would not be able to run the first person like camera. It would be awful. Yeah.
Questions for
All right, congratulations, team. Congratulations, everyone. And I think that's pretty much it. So, congratulations, everyone. There's still that Canvas submission. I do want to be able to see all your code for things. So I left it as kind of vague instructions, somewhat intentionally. Submit what you think I need to see to be able to really evaluate finally your project. I don't want to just look at your slides and say I'll evaluate based on what the slides said. I want to avoid falling into that trap. But I think everyone did a very good job, so I don't think anyone should be concerned about their scores for the project and for the grades for this class. It was really cool to see. It was really cool to see where you've come from. If you want to think back to the first week of the semester, even just in terms of your hardware design skill set and your ability to debug hardware, and then what you've been able to learn in terms of graphics processing as we've gone through this semester. So that was very nice from just my perspective to see, and I hope you feel like you did learn a lot as well. Otherwise, that's it for this semester. I hope to see many of you again after this semester, but if some of you are graduating and leaving and I'll never see you again, that's also fine, but you're always welcome to come back and say hello whenever you've moved on to the next stage of your career. So that's it, and enjoy the rest of your finals week, and finish up strong, okay?